continuing, I had to help a student there. Putting in the wavelengths for these three wavelengths, I'm going to put in the values of 1005 nanometers. Well, 1240 divided by 1005, you can quickly see, well, that's going to be slightly bigger than 1. And in fact, it turns out to be, I may not have actually calculated this, which is ridiculous. I calculated it somewhere, but it's not in my spreadsheet. So let me do it real quick. So I have wavelength 1 is 1005. Wavelength 2 is 2166 nanometers. And wavelength 3 is equal to 4654. And so using that 1240 value, I have, with this one here, it's 1.23 electron volts. And then if I go ahead and change 1005 to 2166, it's going to turn out to be about half of that, and it's actually 0.572. And then if I finally use 4654 in the denominator, I have 1240 by 4654, and it's 0.266 electron volts. So I measured photons of these different energies. And now the instructions here say, go ahead and calculate what the energies are for each of these states in the hydrogen atom. So now I'm going to take my 13.6 minus, so they're all going to be negative, 13.6 divided by 1 squared is, of course, minus 13.6. 13.6 divided by 2 squared is minus 3.40. 13.6 divided by 3 squared is minus 1.55, or 51, excuse me. By 4 squared, which is 16, gives me minus 0.850. Divided by 5 squared, or 25, is minus 0.544. Divided by 6 squared, I have minus 0.378. And 7 squared is 0.278. 8 squared is minus 0.213. And 9 squared is minus 0.168. So I calculate all of these energies. And my instructions say, okay, find the highest level I could have and get the 1.23. Well, 1.23 could occur with any one of these transitions, right? Because this gap is bigger than 1.23. But obviously 3.4 minus 13.6, that's a lot bigger. 1.5 minus 1.5 minus 3.40, well, that's going to be close, but that's in the ballpark of 1.9, not 1.23. So let's keep going. 0.85 to 1.5, well, that's too small. 0.85 to 3.4, that's too big. 0.54 and 1.51, that's 0.9 something. And then you go 3.4. Right, so we keep going, and let's see, 0.3 minus 0.378 minus 0.54 is, well, far less than 1. It needs to go to 1.51, and minus 0.37 minus 1.51 is going to be 1.1 something, not 1.23. And then minus 2.78 minus 1.51. That gives me, the reason I'm going to 1.51 is because I need to try to get to that 1.23. And so if I subtract those, that gives me an energy difference going from 7 to 3. That is And these are both in units of EV. And if I did my math right there, it is going to be 1.23. That matches. So now that I found a match, let's see if I can make the other two. If I can't make the other two, then I have to go on and continue my process. So to go to 0.572, I'm just going to say, well, 0.278 minus 0.572 would be minus 0.850, right? 0.850. And look, there it is, E4. So this here, E7 to E4, is my 0.572 EV. And then I have 0.266. So 0.278, well, minus 0.278 minus what gives me 0.266. So if I put that together, that's going to be 544. And there we go. So this one here is the last one. So what I have is the first transition is going from n initial equals 7 to n final equals 3. This is n initial equals 7 to n final equals 4. And this is n initial equals 7 to n final equals 5. So there's my answer. I started at level 7. All right, that was a straightforward problem, I think. Hopefully you're ready. Perfect.